Hi everyone. Today we'll be talking about transformations. So let's take a look at some vocabulary first. A family of functions is a group of functions with the same characteristics. Today we're going to be looking at the linear characteristics, so functions that form straight lines. A parent function is the simplest function with these characteristics. So a linear parent function is the equation y equals x. With this function here, it has a slope of 1, the coefficient of x is 1, and a y-intercept of 0. There's no plus b. So y equals x is our linear parent function. Alright, so let's come down here and see what happens when we make some changes. So first we're going to graph the parent function in black. So my parent function is going to be a line with a slope of 1 and a y-intercept of 0. So I'm going to start at 0. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I keep going all the way up through, okay, until I get my line. I can do the opposite direction to get the other end. Okay. Down 1, left 1, down 1, left 1, until I get my line drawn all the way through. Remember, when we draw lines, we have to draw all the way through the graph and put arrows on both ends. Alright, so this is my parent function. Now we're going to start making some changes to the parent function. So now we're going to take a look at this one, y equals negative x. I've changed my slope from a positive 1 to a negative 1. I'm going to graph this one in pink. If you have colored pencils or pens or something like that, that would be great to do. You don't have to do it in the exact colors listed here. You can cross off this color and write down whatever color you happen to have. So to do a slope with negative 1, okay, again, it has no y-intercept. I've just changed the sign of my slope. So I start here, and negative 1 means I'm going to go down 1, right 1. Down 1, right 1. And I keep following that pattern until I have enough points to make my line. I can do the opposite. I can go up 1 and left 1 to get the other half of my line. Okay, so what's the difference between the black line and the pink line? Well, we can see that they're going in opposite directions, right? So we can say that the pink is going in the opposite direction, or we can say that it was flipped or reflected. Alright, now let's graph the lines y equals x minus 3 in red and y equals x plus 5 in blue. Alright, I'm going to start with this one here. Alright, so x minus 3. So it has a slope of 1, and this time I'm adding in a y-intercept of negative 3. So to graph this one, I'm going to go down to negative 3, and now to graph my slope of 1, I'm going to go up 1, over 1. Up 1 over 1. I can keep doing that. Up 1 over 1, up 1 over 1. Okay? So let's see, how is the red line different from the black line? Well, we're going to notice that they're parallel, which means they have the same slope, which we can tell by looking. This has a positive 1 slope, and my parent function has a positive 1 slope. But what happened? It looks like that line, it just sits lower on the graph. Okay? The red line is lower on the graph. Alright, now let's see what happens when we graph this one. So again, I have a slope of 1. This time my x-intercept is a positive 5. So I'm going to go up to 5, and then I'm going to go up 1 over 1. Up 1 over 1. And put enough points on there so that I can get that line graphed. Okay? So how are the blue and black lines different? Well, this time, it kind of looks like we just took that black line and moved it up. The blue line sits higher on the graph. All right, let's go ahead and go to the next page. All right, we're going to do another one. This time, we're going to graph the parent function again in black. So I start at the origin. My parent function is y equals x. So I'm going to go up 1 over 1. So here's my parent function. Now, in yellow, I'm going to graph the line 1/2 x. Okay, so now my slope is different. Now I have a slope of 1/2, but I still don't have a y-intercept. So I'm going to start at 0, and this time I'm going to go up 1 over 2. And I can keep following that pattern, up 1 over 2, to get some more points so I can get my line graphed. So now I've got this line. All right, well, how are the black and yellow lines different? Well, now we can see that this yellow line doesn't look quite as steep, right? It actually looks like it sits maybe a little flatter than the original one. It's not as steep. Okay? All right, now let's graph the line y equals 4x. So this time I have a slope of 4. Again, no y-intercept. So I'm going to start at 0, and to graph a slope of 4, I'm going to go up 4 over 1. Do it again, up 4 over 1. Draw my line in. All right, so now how are the black and green lines different? So comparing the black to the green. This time the green line looks a lot steeper, doesn't it? Okay. So we can say that the green line is steeper. All right, so let's talk about those transformations of the parent function. So a translation is a vertical shift up or down. We want to look at the y-intercept to help us determine that vertical shift. If my y-intercept is positive, then it means it's a vertical shift up. If my y-intercept is negative, then it's a vertical shift down. Steepness. Okay? Our slope determines how steep or flat the line appears. The sign in this case does not matter. We'll talk about what that sign means in just a minute. If our slope is greater than 1, then we say the line is steeper. If the slope is between 0 and 1, then we say that the line is flatter. Well, now let's talk about what happens if there's a negative in front. The negative is not going to make it any more steep or less steep. That's just the number itself. The negative instead is what we call a reflection. That's where it gets flipped. So if a slope is negative, then we say there's a reflection. You do not have the word reflection written on your notes, so I do need you to add that in. All right, so let's come down and talk about example 1. So here we're going to describe the transformation of this following equation compared to the parent function. So again, remember the parent function is y equals x. Whenever you see parent function, it's y equals x. All right, well, before we can do anything, before we can describe the transformations, we've got to put this into slope-intercept first. Okay? So we got to have to solve for y. So in order to solve for y, I need to subtract x from both sides. When I do that, that cancels out. And now I'm left with y equals negative x plus 9. All right, so now I've got my equation in slope-intercept form. Now I can take a look at the different components of this equation to determine what type of transformations occurred. So the first thing I'm going to do is look at my slope. I see that I still have a coefficient of 1, but this time it's negative. So the negative means that it's a reflection. Because the number itself is still 1, it didn't get steeper or flatter, that part stayed the same. So we would just say that there's a reflection. Then we can look at the y-intercept. It's a plus 9. That means that we have a vertical shift up 9 units. The positive 9, the positive part tells us that we shifted up. So now, let's go to the next page. I'm going to take a look at these two examples, and then that's it. These are your try on your own. This one here is ready to go for you. This one you're going to need to convert into slope-intercept form before you can determine which transformations happen. This is the end of your notes, so you can stop the video now. Please make sure you complete these two problems before next class. I'll see you then.